morning students. Last class we have already discussed about the introduction of graph theory, and I have told about Königsberg bridge problem. Okay, and also we have studied that how that problem does not have any solution. Euler has founded that problem does not have any solution. Okay, in that way only the graph theory was introduced in this mathematics field. This is one of the concept for the introduction of the graph theory. Okay, now we move on to the first unit that is discussed about the basic definitions and theorems of graph theory. So here we are going to study about graphs, definitions of graphs, subgraphs and examples of graphs, and some basic theorems in graph theory. In the basic theorems in graphs. Okay, basic on these definitions and some theorems we are going to extend the concept. Okay, like Eulerian graph, Hamiltonian graph, connected graphs, trees, all the things we are going to study later. For that concept, this basic is a very important concept. Okay, so now we see the basic definitions of graphs and the corresponding examples now. So here the definition, first definition for a graph, definition of graph. A graph is always denoted by the letter capital G that consists of a finite, that consists of a set V of G comma X of G, where V of G is a non-empty finite set whose elements are called points or vertices, and X of G is a set of unordered pairs of distinct elements of V of G. The elements of X of G are called lines or edges of the graph G. So nothing but we are representing the graph with the letter G. So the G is consist of a pair V of G comma X of G. V of G and X of G is a set, representing the set. Okay, so here V of G is a non-empty finite set whose elements are called points or vertices. V of G is a non-empty finite set. It should be contain an element. For the graph we have to draw means that should contain a vertex. Okay, so it is a non-empty finite set whose elements are called points or vertices. Okay, it should be a non-empty and also a finite set. It could not be a infinite set, it should be a finite set. Okay, so and the elements, each elements in this set is called as points or vertices. These are the words we are going to frequently use in the graph theory. Okay, to define a graph means we need only vertices. Definitely we need a vertices. Okay, and another set is X of G. That is a set of unordered pairs of distinct elements of V of G. Already we have defined V of G, and unordered pairs of the elements of V of G is forming X of G, and these elements are called as lines or edges of the graph. Okay, so the elements of V of G are called vertices or points, and the elements of X of G are called edges or lines. Okay, now we see one example for the graph. If X is equal to the order U comma V belongs to X of G, okay, then the line X is said to join U and V. Usually you are writing like this: X is equal to U comma V. It's an edge or line. This means that the line X join the two points or vertices U and V. U and V are here called as adjacent vertices. So if there is a line between the two vertices U and V, then they are called as adjacent vertices. U and X are incident with each other. Okay, and also you can call U and X are incident with each other. That is, a vertex U and the edge are incident with each other. Okay, this is the way of representation. If x is equal to u comma v, this is a line, okay, that we are representing UV. That means U and V are joined by the line X. And also you can call that U is incident with the X. U and X are incident with each other, or V and X are incident with each other. If two distinct lines X and Y are incident with the common point, then they are called adjacent lines. Okay, so here we call that U and V are adjacent vertices. Okay, if there is a line between U and V, and if two lines are incident with the common point, now then we call that two lines are adjacent lines. Now in this example you can easily understand this concept. Okay, so now the graph we are defining two sets, no, V of G and X of, so it's a graph G1, so V of G1, X of G1. V of G1 having the three elements U, V, W. Okay, finite set. Okay, so three elements we are having, and X of G are having the ordered elements X comma Y we are having here. Okay, X is nothing but U comma V and Y is nothing but U comma W here. So the graph is like that you are having. Okay, X represent U comma V and Y represent U comma W, right? So here we are having that these two lines X and Y are incident on a common point U. So we can call that X and Y are adjacent lines, right? Adjacent meaning another nearby. Okay, here nearby they are having the common elements. X and Y are incident on a common point. Okay, so you have that X and Y are adjacent here, and here also U and V are adjacent because they are joined by a line X, and U and W are also adjacent vertices because Y joins the vertices U and W. But what about this V and W? Is there any line here between V and W? There is no line between V and W. Therefore, V and W are non-adjacent vertices here. Okay, vertices U, V, W are vertices. X and Y are lines. Since X and Y are incident with the common point U, we call that X and Y are adjacent lines. And also this U and V, U and W are adjacent vertices. Here V and W are non-adjacent vertices because there is no line joining V and W. Now next to another come to another example, another graph G2 here. So here again the vertex set of G2 is U, V, W. Okay, three vertices again you are W and Z, four vertices you are having. And next one is X, Y. Okay, X and Y are the two edge sets of X of G, right? Okay, X is nothing but UV and Y is nothing but WZ. This is another graph we are having. Here what about the lines? Whether they are adjacent? No, they are not adjacent lines here because they don't have any common incident vertices. So X is separate, Y is separate here. Okay, so X and Y are non-adjacent lines here, right? And U and V are adjacent vertices, W and Z are adjacent vertices. But here U and W are non-adjacent, V and Z are non-adjacent here. Okay, so I think all of you clear about this concept. Okay, adjacent vertices, adjacent lines, and you have studied now. Now we'll come to one more example here. And you can also always represent for the vertex set the letter V, for the edge set or line set the letter capital X. So notation you are going to use further in further theoretical approach. You will use this notation V and X. V is vertex set and X is the edge set of the particular graph. So here V is equal to A, B, C, D vertex set, 4 elements, and X is equal to A comma B, ordered pair of the elements of V you are having. So X is equal to A comma B, A comma C, A comma D. Okay, so now here you can draw the graph here. So there are 4 points A, B, C, D, and X is lines. Okay, A and B will be joined by a line. Okay, So AB you can draw a line, and another one is A comma C, and AD is joined by this line. So this is a graph G. So you can represent this G is a 4 comma 3 graph. 4 is nothing but number of vertices and 3 is number of edges. Okay. Usually you can call this is P comma Q. P is number of vertices and Q is number of edges here. So G is a 4 comma 3 graph here. Okay. 4 comma 3 graph. Right. So till now you have studied about the definition of graph and next examples of graphs and adjacent vertices, adjacent edges, okay, and non-adjacent edges, non-adjacent vertices, right? Now we move on to the one more example we are having. Let V is equal to 1, 2, 3, 4, okay. So this is 4 element we are having, and X is equal to 1 comma 2, 1 comma 3, 1 comma 4, 2, 3, 2, 4 and 3, 4. Now this graph, how many edges we are having here? 6 edges we are having. So this graph G is a 4 comma 6 graph. So 4 comma 6 graph, we can draw the graph corresponding to these two details. So you are having 4 vertices. Just first you have to plot the vertices 1, 2, 3, 4, and next you have to join the lines here. So 1, 2 and another one is 1, 3. So this line you have to draw. Then 1, 4, this one, then 2, 3, 2, 4 and 3, 4, right? So this is a graph representation of this given two sets. The another same graph for the this representation. So we are having more than one graph representation for the given set. Okay, next one is you can same graph we are drawing like this. 1, 2, 3 and 4 we are putting the vertices inside this triangle. So we are having the another graph. Okay, these two graphs are same graphs we are having. Next one is Peterson graph. This is a special graph. Okay, 10 vertices and 15 edges we are having here, and this graph has a name as Peterson graph. We will study about this Peterson graph later in the 3rd or 4th unit. We will study about this graph. Okay. So this is the graph, Peterson graph. Just you draw the pentagon outside. 1, 2, 3, 4, 5. Okay, one pentagon you have to draw, and inside again you put 5 vertices. Okay, A, B, C, D, E. Then you draw the star connecting these A, B, C, D, E, and each node you join with this corresponding vertices. Okay, A to 1, B to 2, C to 3, D to 4, E to 5. Okay, this is a Peterson graph, right? So these are examples for graphs. Okay, now we move on to the next definition, that is a line joining a point to itself is called a loop. Okay, so line is nothing but a edge joining 2 points. Suppose if a line joining a point to itself is called a loop. If more than one line joining 2 vertices are allowed, the resulting graph is called a multigraph. Or more than one line joining 2 vertices. Okay, suppose if you are next example you can see. So here you can see that the definition. So first definition I told you, loop. Okay, a loop is nothing but a line joining a point to itself. So here you are having this loop. Loop means this is the meaning. You already know that the meaning of the loop, no? So this one. Okay. So C is the point here you are having, and the edge 8. Here name is 8. Here edge name is 8. So 8 is joining the vertex E to itself. Okay, vertex E to itself. So this is called as a loop here. Okay, 8. The 8, the line that is named as 8 is loop here. Okay, in this graph. Next one is a multiple lines. Okay, the lines joining the same points are called multiple lines. Same points. Okay, suppose if you are having this A and B. These are the 2 points. Now the lines 1 and 7 are joining the same 2 points A and D. Okay, so the line joining the same points are called multiple lines. Line joining the same points are called multiple lines. So 1 and 7. Okay, these two lines are multiple lines. Now you come to this definition, multigraph. If more than one line joining two vertices are allowed, the resulting graph is called a multigraph. So this graph is called a multigraph because that two vertices A and D, also this A and B. A and B is also joined by two lines. Okay, B and 2. Okay, so this graph is also called a multigraph because this graph is having multiple lines. If loops are allowed, the graph is called a pseudograph. So in a graph, suppose loop is occurs means that graph is called a pseudograph. Now without this edge 8 means the graph we can call as multigraph. With this loop we can call the graph as a pseudograph. Okay, that's why I am writing here the line 8 is loop and 1, 7, 2, 6 are multiple lines here. Okay, so what are the things we have studied here? This is loop, multigraph, multiple lines, pseudograph. Okay, so loop is a line joining a point to itself is called a loop, and multigraph means multiple lines occur arrangement, that's graph is called as a multigraph. Okay, line joining the same points are called multiple lines. At the next, multigraph means if more than one line joining two vertices are allowed, the resulting graph is called a multigraph. If loops are allowed, the graph is called a pseudograph. Loops means line joining to a point to itself. So loops are occurs in the graph means that graph is called a pseudograph. If multiple lines and multiple lines occurs means that is called as a multigraph. Okay, so if loop occurs, that called as a pseudograph. Now this is already I have told you, P in this number of vertices, this representation. Here further all the concept we are going to use this notation P and Q. P is number of vertices, Q is number of edges. Okay, so there is a relation between P and Q here. Number of edges is always less than or equal to PC2. Okay, number of edges less than or equal to PC2, and if equal to occurs if and only if any two distinct points are adjacent. Any two distinct points are adjacent, Anjana, this number of edges is equal to PC2. Just you check the previous graphs, Q is less than or equal to PC2, no? So just you take this graph. Already you have seen this graph, no? You can come to the second example. Here how many edges you are having? 3 edges. Okay, this one. Okay, 3 edges. How many vertices you have? 1, 2, 3, 4. Okay, 4 vertices you are having. So this 4C2 value is, what is 4C2? 4 into 3 divided by 1 into 2. So you have that value is 6. Okay, so 6, PC2 value is 6, and here number of edges is 3. So 3 less than 6 you are having. Okay, and now you come to this one, this graph. Okay, so this third example. So here any two distinct vertices are adjacent. One is adjacent to 4, 3, 2, because we are having the line joining 1 to 2, 1 to 3, 1 to 4. And 2, if you are concentrating on 2 means again that is adjacent to remaining 3 vertices. Now we come to 3, that is also adjacent to remaining 3. 4 is also adjacent to remaining 3 vertices. So here all the distinct vertices are adjacent to each other. Now you count the number of vertices and the number of edges here. So number of vertices is 4. Number of edges is 1, 2, 3, 4, 5, 6. 6 edges you are having here, right? So 6 edges and 4 vertices we are having. So 4C2 value is 6. Just now we have found out. So 4C2 is 6 and the number of edges is also 6. So Q is equal to PC2 here. That means you have seen the note if and only if any two distinct vertices are adjacent to each other, right? So this is the example for this one. Okay, now are you clear this concept? Number of edges is equal to PC2 if and only if any two distinct points are adjacent. Right. Now next we move on to another definition. A graph in which any two distinct points are adjacent is called a complete graph. Okay, graph in which any two distinct points are adjacent is called a complete graph. Okay, so the complete graph with p vertices is denoted by this notation KP. Okay, complete graph with p vertices is denoted by KP. So any two vertices should be adjacent. Any two distinct points are adjacent. Now that graph is called as a complete graph. Okay, KP, complete graph with p vertices. Now this is example for complete graphs. K1, first one, K1 means complete graph with one vertex. So only one vertex. Okay, so there is no edge here, because the definition you have told that any two distinct points are adjacent. Okay, so if we can draw the loop here, but the loop is joined points to itself. Okay, so but the definition is any two distinct points, different points join ஆயிருந்திருக்கும். Okay, adjacent இருக்கும். Then only call that graph is complete graph. So here there is no possibilities of no possibility of drawing the edge here. So this is K1. K1 is nothing but a single vertex. Now K2. K2 means complete graph with two vertices. So V1, V2, that should be adjacent. Okay, so there should be an edge between V1 and V2. So this is K2. V1, V2. Next K3, we have the three vertices. V1, V2, V3. Three vertices you are having, and this is a complete graph. Each distinct vertices adjacent to each other. So V1 adjacent to V2, V1 adjacent to V3. Similarly, remaining two vertices, V2 adjacent to V1 and V3. V3 adjacent to V1 and V2. Now K3 is nothing but a triangle. Okay, now similarly K4. This graph already was seen the example of a graph. K4 with 4 vertices such that any two distinct vertices are adjacent to each other. So V1, V2, V3, V4 adjacent to each other. Likewise K5, K6. Now you can try that K5 and K6 to yourself how to draw this one. Okay, K5, K6. Okay. Now we move on to the next definition. A graph whose edge set is empty is called a null graph or a totally disconnected graph. Another definition. Null graph or totally disconnected graph. A graph whose edge set is empty is called a null graph or a totally disconnected graph. So we have only 4 points here. Okay, no edges. So this is called a null graph or totally disconnected graph. In the connection we don't have any connections between vertices. So this is a totally disconnected graph. Example this one. Next definition, a graph G is called labeled F if its P points are distinguished from one another by names V1, V2 up to Vp. Labeled graph vertices should be named. Okay, labeled by the vertices V1, V2 up to Vp. This is called the labeled graph. Labeled graph, already we have labeled the vertices. These are examples for labeled graph V1, V2. We have already labeled this. Okay, this is labeled graph. Next definition is bipartition of a graph G. Bipartition graph. Okay. Now this one, a graph G is called bigraph or bipartite graph if V can be partitioned into two disjoint subsets V1 and V2 such that every line of G joins a points of V1 to a point of V2, V1 comma V2 is called a bipartition of G. Okay. So partition, bipartition. Bi, now what is the meaning by? Bi represents 2. Partition means it's divided. Okay, divided into 2. Okay, which one we are dividing into? The vertex at V. Okay, so in the vertex at V we are dividing as a 2 disjoint subsets V1 and V2, right? Okay, this is regarding to vertex set of a bipartition. Next one is I will come to the edge set. Edge set. Okay, so this such that every line of G joins a point of V1 to a point of V2. So all the lines in the graph G எப்படி இருக்கணும்னா that should join a point of V1 and a point of V2. Then in the மாதிரி conditionல இருந்துச்சுனா then we call that G is a bipartition graph. It's called a bipartition of G. Okay, so once again repeat, by the name itself you can understand the concept. Bipartition, bi is 2, partition is divided. So we are dividing the vertex set V into two disjoint subsets. Okay, disjoint is important. There should not be any common element between the two sets. Okay, each set is distinct from another set. Okay, adhan we are calling this here disjoint subset. Disjoint is very very important here. Okay, so disjoint subsets V1 and V2, and the edges of G's are joining a point of V1 to a joint point of V2. This is called bipartition of G. Another one is complete bigraph. Complete bigraph or complete bipartite graph. Okay, bipartite graph, bigraph, all are representing the same concept. All are representing the same concept. So if G contains every line joining the points of V1 to the points of V2, then G is called a complete bigraph. Okay, if G contains every line joining the points of V1 to the points of V2, then G is called a complete bigraph. All the lines are joining from V1 to V2. Okay, then all the vertices are here adjacent to each other. So this is called the complete bigraph. Okay, so here some example of a complete bigraph. So this is a notation we are using to represent complete bigraph K, M, N. Already I have studied the complete graph. No, complete graph with the P vertices. No, that is KP. KP representing the complete graph with the P vertices. Now K, M, N na, that is a complete bipartite graph. Okay, that means this M represent number of vertices in one set V1, and N is represent number of vertices in another set V2. So if V1 contains M points and V2 contains N points, then the complete bigraph is denoted by K of M, N. Okay, so V1 contains M points and V2 contains N points. Then the complete bigraph is denoted by K, M, N. So here some example for complete bipartite graph. K33, 1, 2, 3. Okay, V1, V2, V3. This is called one set V1. Okay, and the remaining we can call as V2. Okay, so V4, V5, V6. Now all the vertices of V1, capital V1 is joined all the vertices of V2. Okay, see here V1, this one adjacent to these 3 vertices, and the middle point adjacent to the remaining 3 vertices. But there is no line between the points within the set. Okay, V1, V2, V3, there is no line. They are distinct. Okay, similarly this set V2 also there is no line joining these 3 points. Okay, So these are this is called a complete bipartite graph, k3 comma 3, and this is k1 comma 3. Capital V1 having only one vertex and capital V2 having 3 vertices. Capital V2 having 3 vertices. So if you are joining this, we have these things. Okay, this is k13. Now k1 comma m is called a star graph for n greater than or equal to 1. So the graph like this we are calling that as a star graph for n greater than or equal to 1. Okay, so k1 comma m is called a star graph here, right? So now what we have studied here, so we have studied from the beginning. Once again I explain the concept or recall that once. So today's class we have studied that graphs and subgraphs, graphs definitions and the examples and some more definitions of graphs. So first one is graph definition, means it consists of a pair V of g, x of g. V of g is a non-empty finite set. X of g is a ordered pair of elements of V. Now the V of g elements are called as vertices or points, and x of g elements are called edges or lines of the graph G. If x is equal to u comma v belongs to x of g, the line x is said to join u and v. U and v are adjacent vertices, u and x are incident v. Okay. And the next one is two distinct lines x and y are incident with a common point. Now we call them as adjacent lines or adjacent edges. Some examples we have studied. And next one is a Peterson graph. Okay, 10 comma 15, 10 number of vertices, 15 number of edges. This is Peterson graph. Then a line joining a point to itself, now it's called as a loop. Adutha multi lines. If line joining the same points are called multiple lines. If the graph having multiple lines, now that is called a multi-graph. If the graph having a loop, now that is called a pseudo-graph. And the notation P and Q, number of vertices and number of vertices. The relation between P and Q is always less than or equal to PC2, and Q is equal to PC2 now if and only if any two distinct points are adjacent. The next one is a complete graph. Complete graph means any two distinct points are adjacent. It's called as a complete graph. Some examples we have seen. The next one is a null graph. Edge set is empty. A graph in which edge set is empty means it's a null graph. Or you can call this a totally disconnected graph. Then a labeled graph. Labeled graph means is each vertices should be having the distinct label V1, V2 and so on VP will have. Next definition, a graph G is called a bigraph or bipartite graph if V can be partitioned into two disjoint subsets V1 and V2 such that every line of G joins a point of V1 to a joins of V2. If every line joining the points of V to the points of V2, then the G is called as a complete bigraph. So here we have the notation K m comma n, complete bipartite graph, m vertices and n vertices. V1 having m vertices, V2 having n vertices. So K33 from example you have seen, and K1 comma 3 is that is called as a special name star graph for n is greater than or equal to 1. Okay, so this is the thing we have studied here, and we can try yourself for the drawing of the graphs, how we can draw the graphs and how can we give the examples. You can do it yourself. Now I will give some exercise to you, how to exercise problems, and you can do it in your notebook here. Draw all graphs and 4 points. So first problem, draw all graphs with 1 vertex, 2 vertices, next 3 vertices and 4 vertices. You have to draw maximum graphs with the 2, 3 and 4 vertices. Okay, then second problem. First problem once again repeat. Draw all graphs with 1, 2, 3 and 4 points. Second problem, find the number of points and lines in K, M, N. Find the number of points and lines in K, M, N. So generally K, M, N la எவ்வளவு points இருக்கும் எவ்வளவு lines இருக்கும் கேட்டிருக்காங்க. Number of points and number of lines. You can do it by drawing K11, K12, K13, K14, 2, 1, 2, 3, 2, 2. Okay, M is even, M is odd. You can consider like that. Both are odd, both are even. Okay, one is odd, one is even, and one is even, one is odd. Generalize பண்ணிட்டு அடுத்து ஃபைனலாக எனக்கு ஆன்சர் சொல்லணும். Okay, so you can do these two problems. Now you do these two problems and tell me the answer and show your graphs what you have drawn.